Now, the transfer section of midbrain at the level of superior colliculus. Transfer section at the level of superior colliculus. At this level, the structure of crus cerebri and substantia nigra, they remain the same. The tegmentum contains grey matter and white matter. In grey matter, we will get some important nuclei. They are red nucleus, third down nucleus, the pretectal nucleus, and mesencephalic nucleus. Red nucleus, third down nucleus, pretectal nucleus, and mesencephalic nucleus. Red nucleus is a large overt mass of grey matter related to extrapyramidal system. This lies dorsomedial to the substantia nigra. The red nucleus, large mass of grey matter containing multipolar neuron and is related to extrapyramidal system. This contains small cells and large cells. Small cells are present in all parts of the red nucleus, and the large cells are phylogenetically older cells. They are found in the caudal part of the red nucleus. The red nuclei, they extend up to the subthalamic region. This is called red nucleus because in fresh preparation it appears red because of its high vascularity and also because of the cells which contain pigments in them. The red nucleus receives fibers from afferent fibers from cerebellar nuclei, globus pallidus, subthalamic and hypothalamic nuclei, subthalamic and hypothalamic nuclei. It also receives fibers from substantia nigra and from the spinal cord. These are the afferent fibers, afferent to the red nucleus, and the efferent fiber emerging from the red nucleus, they decussate in the median plane. They decussate, they cross to the opposite side, and this decussation is known as ventral tegmental decussation. This is ventral tegmental decussation. Ventral tegmental decussation. And after decussation, they descend down to the reticular formation of the brain stem and to the spinal cord. And rubro-reticular tract, different from this, they go to the reticular formation, forming a tract, the rubro-reticular tract and the rubrospinal tract. Rubrospinal tract. This is the red nucleus. Then there are third nerve nuclei. Third nerve nuclei. Third nerve nuclei. They are found in the floor of the aqueduct of Savior. Suppose this is the aqueduct. This is the position of the third nerve nucleus. This is third nerve nucleus. The third nerve nucleus has various subnuclei. They are known as ventral, dorsal, ventromedial, caudal central, intermediate, and Edinger-Westphal. Nuclei. These are the subnuclei: ventral, dorsal, ventromedial, caudal central, intermediate, and Edinger-Westphal. These nuclei, the ventral, dorsal, ventromedial, caudal central, and intermediate, they supply the extraocular muscles of the eyeball. Now the third nerve nuclei, these are the nuclei. This part, the ventral, dorsal, ventromedial, caudal central, and intermediate, they supply the extraocular muscle of the eyeball. Extraocular muscles of the eyeball. And the fibers emerging from these will have somatic efferent component. And the Edinger-Westphal nucleus gives out parasympathetic fibers, and this supplies sphincter pupilli, and ciliaris muscle. Sphincter pupilli and ciliaris, parasympathetic fibers. Therefore, the functional component will be general visceral efferent. Therefore, the third nerve has two components: somatic efferent and general visceral efferent. The third nerve gives out fibers which passes through the red nucleus, crosses the substantia nigra, and emerges on the medial surface of the crus cerebri. This is third nerve. The third nerve receives fibers from the cerebral cortex as corticobulbar tract. Corticobulbar tract. This is connected to medial longitudinal fasciculus. Then the superior colliculus, they also give out fibers as tegmental tract. And the third term nucleus is connected to the pretectal nucleus also. Pretectal nucleus. Therefore, the third nerve nucleus receives afferent from the cortex as corticobulbar tract connected to medial longitudinal fasciculus, from superior colliculus as tegmental tract, and this is connected, or this receives fibers from pretectal nucleus. Then the pretectal nucleus. Pretectal nucleus. This is a mass of grey matter situated ventral to the superior colliculus. And this receives fibers from the retina and gives out fibers to the third nerve nucleus. This will receive fibers from the retina and gives out fibers to the third. The pretectal nucleus comes in visual reflex pathway. In this way, we are seeing the grey matter as red nucleus, third nerve nucleus, pretectal nucleus, and also the superior colliculus. And these collections of grey masses, they are related to visual reflex pathways. Now, let us try to understand the visual reflexes. Visual reflexes. There are three types of visual reflexes. The spino-visual reflex, light reflex, and accomodation reflex. We know about the spino-visual reflex. Let us try to understand the light reflex and accommodation reflex. Light reflex. Light reflex is a constriction of the pupil in response to the light thrown in the eyes. The light reflexes of two types: direct light reflexes and indirect or consensual light reflex. Direct light reflex, this is constriction of the pupil of the same eye on which light is thrown. And indirect light reflex is constriction of the pupil of the opposite eye Now what is the pathway? Light reflex pathway. This is coming from the retina through optic nerve. Optic nerve, this goes to optic tract. Optic tract. And from the optic tract, the fibers pass to pretectal nuclei of both sides. Of both sides. Pretectal nuclei of both sides. And from pretectal nuclei of both sides, the fibers will go to the third nerve nuclei of both sides. Of both sides. And in this case, the nucleus is Edinger-Westphal. Edinger-Westphal nucleus. Edinger-Westphal nucleus. Fibers emerge from the Edinger-Westphal nucleus. They enter into third nerve. Third nerve. Now the third nerve gives out a branch, the nerve to inferior oblique. The fibers coming from the Edinger-Westphal nucleus, this traverses through the nerve to inferior oblique muscle of eyeball. And the fibers from the nerve to inferior oblique muscle of the eyeball goes to ciliary ganglion. Ciliary ganglion, one of the parasympathetic ganglion. Ciliary ganglion, and from ciliary ganglion, short ciliary nerves come out which supply the sphincter pupillae muscle. From ciliary ganglion, short ciliary nerve emerge. Short ciliary nerve. And this will supply the sphincter pupillae muscle of the eyeball, resulting in constriction of the eye. Suppose light is thrown on the right eye, this will go to the retina and then optic nerve and optic tract of the same side, and from the optic tract the fibers come out and they go to the pretectal nuclei of both sides. And from this pretectal nucleus, the fibers, they pass to Edinger-Westphal nucleus of both sides, and fibers from the nucleus emerge as third nerve, and third nerve gives out a branch which is known as nerve to inferior oblique muscle of eyeball, and this enters into the parasympathetic ganglion related to it, the ciliary ganglion, and from ciliary ganglion, short ciliary nerves come out and they supply the sphincter pupillae muscle. Sphincter pupillae. In this way, the short ciliary nerves of both sides will enter into the eyeball and they will act on sphincter pupillae muscles of both sides. Since it is going to both sides, there will be constriction of the pupil of the opposite eye also, with the constriction of the same eye. This is light reflex pathway. Now, the accommodation reflex. Accommodation reflex. Accommodation reflex. When the gaze is changed from a distant object to a near object suddenly. Some changes take place in the eyes. And this is known as accommodation reflex. And the changes which take place are medial deviation of the eye, medial deviation of the eyeball, constriction of the pupil, constriction of the pupil, and change in refractive index of the lens, the thickening of the lens. The medial deviation takes place by medial rectus muscle, medial rectus, constriction of pupil by sphincter pupillae, and thickening by ciliaris muscle. Ciliaris muscle. Now, what is the pathway for accommodation reflex? Accommodation reflex. This starts from retina, then through optic nerve, goes to optic tract, then to lateral geniculate body, and from lateral geniculate body, fibers of optic radiation start. Optic radiation, this goes to visual cortex present in occipital lobe. Visual cortex. Now, the fibers or the sensation from the visual cortex, this goes to frontal eye field. Frontal eye field. Frontal eye field. Frontal eye field, and from frontal eye field, the corticobulbar tract starts. Corticobulbar tract. Corticobulbar tract. Corticobulbar tract will go to third nerve, nucleus. This goes to third nerve, nucleus. Third nerve, nucleus. Third nerve, nucleus. This gives out third nerve. Third nerve. Then nerve to medial. Nerve to medial rectus muscle of the eyeball. Nerve to medial rectus. In this way, there will be contraction of the medial rectus muscle and deviation of the eyeball medial. The fibers from the corticobulbar tract, as it is going to third nerve nucleus, this goes to the Edinger-Westphal nucleus. Edinger, one of the components of third nerve nucleus. Edinger-Westphal nucleus. Edinger-Westphal nucleus is one of the components of third nerve nucleus. And Edinger-Westphal nucleus fibers emerge as third nerve. Then one of its branches, nerve to inferior oblique. Nerve to inferior oblique, this enters into ciliary ganglion. And from ciliary ganglion, short ciliary nerve comes out, short ciliary nerve. And short ciliary nerves, they supply the sphincter pupillae muscle, which causes constriction of the pupil, and these fibers, they also supply ciliaris muscle, which results in thickening of contraction of ciliaris and thickening of the lens. In this way, we can accommodate our vision from a distant object to a near object. These are the collections of grey matter. Now coming to the white matter. White matter. In white matter, we have seen the rubrospinal or this part, reticular fibers, they cross to the opposite side as ventral tegmental decussation. The fibers emerging from the superior colliculus. The fibers coming out from the superior colliculus, they also cross in the median plane. And this crossing is known as dorsal tegmental decussation. Therefore, there will be ventral tegmental decussation. The fibers from the rubrospinal or reticulus, rubrospinal, reticular tract. Rubrospinal or reticular tract. Then there is dorsal tegmental decussation. This is decussation of fibers from the superior colliculus, and this is decussation the tectobulbar tract. Tectobulbar or tectospinal. Tectobulbar tract or tectospinal tract. Besides this, in this region, we will get the medial longitudinal fasciculus. This is the bundle, the medial longitudinal fasciculus. Medial longitudinal fasciculus. Besides that, we will get the lemniscal system. Lemniscal. In this, we will get the medial lemniscus on both sides, the trigeminal and spinal lemniscus. Trigeminal and spinal lemniscus. The lateral lemniscus is not present in this region because this has terminated in the inferior colliculus. Just to label the diagram, this is superior colliculus, This nucleus is pretectal nucleus. This is third nerve nucleus. third nerve nucleus. This part is medial longitudinal fasciculus. This is medial lemniscus. This large nucleus is red nucleus. Red nucleus. This part is the substantia nigra. This is crus cerebri. Crus cerebri. This nerve is third nerve. This is third nerve, and these two are the trigeminal and spinal lemniscus. Trigeminal spinal lemniscus. Trigeminal and spinal lemniscus. This is cross section of the midbrain at the level of superior cortex.